So now that we've talked about the order of processing, and I mentioned how order of processing was not something you have much control over, let's talk about a related topic that you do have some more control over, which is the order of the results. And I'll talk about what it means to differentiate between order of processing and the order of results. So the results of parallel stream computations have more options for you to control than the order of processing. That may seem a little weird at first, but if you think about it, it makes sense. The order of processing is the order those chunks run. The order of the results is the order in which the information in the chunks as they complete will be put back together for ultimate access and use by the program. And this is something you have control over. And programmers control if the results are going to be presented in something called encounter order. And we've talked a bit about encounter order before, but we'll talk a bit more about it now, and hopefully it'll make sense. The easiest way to think about encounter order is just the order in which the data shows up from the source. And usually, the best way to sort of think about it logically is kind of left to right. So if you had an array or a list or something, encounter order is the order in which the elements are encountered, starting from the 0th location to the 1st location to the 2nd location to the 3rd location, and so on and so forth. So it's essentially the order in which the stream source, like an array or a list or a hash set or whatever, makes the elements available. Now, encounter order will be maintained under certain circumstances. In particular, if the source has so-called the ordered bit set or the ordered flag set. We'll talk more about what it means to have the ordered flag set in a second. And if the operations that are used to transform the stream and to reduce the stream also are obliged to maintain that order. Now, at the first glance, this seems very mysterious and weird, but when you break it down, it's actually not that complicated. But it does help to understand the properties of the collections and the operations, and we'll talk about those in these videos. The semantics of whether the results are ordered or not is independent or orthogonal to whether the stream is parallel or sequential. You have the same semantics whether it's parallel or sequential. In much the same way that, if you have something that's in miles per hour, then or in kilometers per hour, the fact you have different readings doesn't mean you're not going the same speed. It's just you're using a different scale. However, the performance may differ, and this is a little bit interesting at first. It turns out if you really want to enforce encounter order in the results, it'll often incur additional overhead for your system, because getting things back in order takes more time and more space than just letting them appear in whatever order they happen to be processed. So if you are willing to live with unordered results, you can often be faster, whereas if you want to enforce an ordering, it's often slower. And that kind of makes sense. You can imagine that in everyday life. If you need to order things, then it typically takes a longer time. So I'm going to give a bunch of examples here, and we're going to look at this in detail as we go through these different steps. So we're going to talk about a couple of different elements, and I'll use a particular example here that comes from this folder in my GitHub account. Okay.